Welcome to today's tutorial. So let's see how we can apply the factors that affect the equilibrium position in this reaction at equilibrium. So here, delta H is negative, showing that the reaction is an exothermic reaction. Remember, delta H is the heat content of a reaction, which is heat content of the product minus heat content of the reactant. So for delta H to be negative shows that the heat content of the product is less than the heat content of the reactant. So since this is an exothermic reaction, if we want to shift the equilibrium position to the right, then we are going to decrease the temperature. So here, a decrease in temperature shifts the equilibrium position to the right, favoring the manufacture of sulfur 6 oxide. Then considering pressure, the total volume of the reactant will be 2 plus 1, which is 3 volume. The total here is 2 volume. Since the total volume of the reactant is greater than the total volume of the product, an increase in pressure shifts the equilibrium position to the right, favoring the manufacture of what? Sulfur 6 oxide, and vice versa. Then for concentration, an increase in the concentration of either sulfur 4 oxide or oxygen shifts the equilibrium position to the right. Even a decrease in the concentration of sulfur 6 oxide will also shift the equilibrium position to the right, and vice versa. Then let's consider this other reaction. 4 molecules of ammonia gas reacting with 5 molecules of oxygen to produce 4 molecules of nitrogen 2 oxide plus 6 molecules of steam. And the delta H of this reaction is also negative. This is an exothermic reaction. So in this reaction, a decrease in temperature will also shift the equilibrium position to the right, since the reaction is exothermic. Now we come to pressure. The total volume here is 4 plus 5, which is 9. The total volume here is 4 plus 6, which is 10. Here, the total volume of the reactant is less than the total volume of the product. So if you want to shift the equilibrium position to the right, we are instead going to decrease the pressure, because decreasing pressure means you are increasing volume according to Boyle's law. So here, since the total volume of the reactant is less than the total volume of the product, a decrease in pressure shifts the equilibrium position to the right, favoring the manufacture of what? Nitrogen 2 oxide. That would be used in the manufacture of triazonitrate 5 acid. Then, in terms of concentration, an increase in the concentration of either ammonia gas or oxygen gas, yes, or a decrease in the concentration of nitrogen 2 oxide will shift the equilibrium position to the right. Conversely, a decrease in the concentration of ammonia or oxygen gas or an increase in the concentration of nitrogen 2 oxide shifts the equilibrium position to the left. Thanks for watching my video.